at least it was. I mean, it was like 10 years ago I did it, but it's like, yeah, an advertising.
Yeah, so whatever's on the main screen is what they'll see at home. But the mics will be on. And I've got that all set up for.
Cool.
I want to hire you. All right.
Okay. No, I'm just kidding. I think we're ready to get started here. Okay, so hello everybody. Thank you for making it out tonight. My name is Levi Zitting. I am the new president of Springfield Devs. Thank you. There's a few announcements I want to go over really quick. Number one, I'm actually going to bring up our previous president, Mike Bates, to talk about a recent partnership that Springfield Devs has entered into. I'll let him give all the details. Yeah.
Get this message queued up here. And my notes.
Sorry. I thought you were going to talk for a couple.
I should have told you were first.
This last president, am I right?
Previous administration. All right. How's everyone doing tonight?
Doing great, how are you?
Good. Are we streaming? Okay, perfect. Sorry. Good God. All right, he's in. Clearly, yeah, okay. All right, so, Levi, thanks for the introduction, and sorry for the weird delay here. Okay, so, we have something pretty exciting to talk about, and that is a new partner that we're bringing on. So, you've probably seen our sponsors. They're on the website. We talk about them. We love our sponsors, absolutely. But we're doing something a little bit different with the new one we're bringing on. And so we've got Andrew up here, and he's going to talk in just a bit. But I'm going to kind of tee things up for you guys, let you know what's going on, and then turn it over to Andrew to introduce himself and talk a little bit more about some of the details here. So Andrew is head of technology for a venture capital firm based out of Los Angeles. You might be asking yourself, what in the hell is a LA-based, venture firm doing in bed with Springfield Devs? What's going on? Andrew's actually got a lot of ties back to this area. And it was actually these connections through eFactory and Rachel Anderson, who is a previous business partner of Andrew's and runs the eFactory. What's funny? Okay. Just make sure nothing's going wrong. And it was through connections there that Andrew and I crossed paths. And so through his journey with this VC firm that he operates in, they invest a lot in tech. And as you can imagine, there's a lot of vetting that goes on with companies that are looking for investment and firms looking to invest in. And so Andrew has been kind of curious about how can they vet these companies, right? He's no stranger to the dev world, but how do you get some real world testing with companies you're looking to invest in? He kind of dipped his toes into the Springfield Devs Discord. If some of you might remember, somebody came in and started posting about this company called Fig, and I didn't even know it was Andrew or where he was from, but I clicked on Fig and checked it out, and it's a really cool kind of command line terminal helper augmentation. It gives you some auto completion and a lot of tools for running command line, and I think a bunch of us were quite smitten with it and thought it was really cool stuff. Come to find out, it was Andrew with Anthos, and that's a company they've been kind of looking into, and so on and so forth. And so this finally led to a conversation of what would it look like to have a community of developers giving real-world feedback into technology like this to a VC firm for companies they're looking to invest in. And so that is exactly what we're going to start exploring. And we're going to figure this out along the way, but the gist of it is going to be we're going to have a couple of channels dedicated in Discord. One of them is going to be an open one that anybody can see and have access to. And we'll post probably high-level details in there. So when Andrew has a company or a product that he's interested in and soliciting feedback on, we'll probably post it in there so that everyone can see it. But to keep down on the noise of that chatter going on, we'll then have a channel that's locked down permission just to people who have said that they wanted to participate in checking that out, giving feedback, all that good stuff. And so, like I said, we're going to feel this out and see how it goes, and hopefully it's a good thing. Andrew's going to fill in a lot of the gaps here. I didn't want to get too much into his story and his involvement and some of the cool things that he has in mind, but we think this is going to be pretty awesome. We don't want this to be the man stepping in with, big monies and whatnot, and then, tainting everything. It's gonna be a lot cooler than that. But Andrew, if you want to go ahead and fill in the gaps that I left there and tell everyone who you are and what Anthos is about. Oh, it's probably delayed too, so he'll hear me in a bit.
No, it's not. That's real time. He just needs to unmute.
1 sec.
Or is he watching the stream?
He's watching the stream.
Oh, then yes.
You're good to go, Andrew.
All right, can you hear me now? Sorry, I was watching the live stream and realizing that it's like a 90-second delay from reality, and I realized, oh wait, they're going to cut to me like any second. I'm watching the live stream for a couple minutes ago. So I don't know what you said in the last 2 minutes of your intro, but I'll just dive right in and take it from there. How's that sound?
That sounds fantastic.
I'm hoping everybody can hear me. Okay, good. All right, you can. All right, cool. Yeah, thanks, Mike, for the intro. The firm I work for is based out of LA. I actually live out on the eastern end of Long Island, where I am right now. This isn't my normal office. I unfortunately got COVID yesterday, so I'm hiding out from the rest of the family. But anyway, I actually grew up in Republic. I went to Republic High School, graduated in 2004, and then went to Mizzou, graduated in 2007 from there, and then lived in St. Louis for a little bit before I moved out to New York in 2008 or so. I've been through the startup roller coaster. I describe it as being a recovering startup founder. And so I joined a small startup here in New York when I first moved out, and it went from, I was the 11th person and we were 150 within a year, raised a bunch of money and had a wild time. And then a few years later, I founded Alumni Spaces with Nick Trusty and Rachel Anderson, who you guys probably are familiar with from the eFactory. And then fast forward a couple of other ventures, and I joined Anthos Capital last year as the head of technology. And that was really, I was sort of the first person brought in to pay attention to the tools and processes that we use to do our jobs. And it's kind of the through line is I found a niche of helping companies scale. It turns out VCs have the same problems in scaling teams as we've grown from 15 to 50 in the past 2.5 years, which is not meteoric by startup standards, but is very fast by finance standards. And what I've realized is that everybody has the same problems with scaling. It's just that on the venture capital side, there's more zeros at the end of both the problems and the solutions. And so it's been an interesting ride coming in, really focusing internally on how we use technology to do our jobs. And what's been fun is I tell people I have the best job in VC because I don't have to actually make any decisions about what we put money into. So I get to sleep well at night. But I get to have an opinion and be a part of the vetting process, which is a lot of fun for me. Because you really get to kind of dive in deep on both the product and the business side of the things you're looking at. So Anthos as a fund is and that fund was about $1.5 billion to start. And a significant portion of it remains as dry powder to be invested. And we tend to invest at the growth stage, which we define roughly as the stage where a company has some level of product market fit. It might be imperfect, but they know what the product is. They know who the customer is and what the pain points are. And they have really good traction indicators behind it. And they might not have the perfect economic model yet. They might not have figured out the units of scale and return models and things like that. So we step in as the funding bridge to basically take you from like, oh, we think we have this product to actually getting to a point where even if you're not quite profitable, like you can see where profitability lies. And so we sort of like help with that part of the on-ramp. We're a generalist fund, and our portfolio ranges from consumer brands, some like hair care products like Olaplex and Curology, fashion, like Trunk Club was one of our early investments, gaming. We are a big investor in VR chat, Axie Infinity, which unfortunately was in the news recently for not the greatest reasons of crypto hacking. And we actually have a small position in Discord as well. And we do some big, hairy, crazy ideas like large scale technology around Carbon Robotics is a company that does autonomous weeding things for farms. Like they go out, it's a big autonomous truck that goes out and like uses lasers to kill weeds, which is a lot of fun. And Parallel Systems is electrifying railroad transportation. So we kind of run the gambit across our portfolio. And some of those, and actually probably the biggest one that people know about, which was one of our biggest exits recently, was Honey, the browser extension that was acquired by PayPal a couple years ago. And on the developer tool side, some of our bigger investments are things like TerraTrue, which is a data privacy platform as a service, ProdPerfect, which is a QA automation platform, and if anybody's in IT, maybe you use Adigy to manage the Macs that are spread across your organization. We have a sizable position in Adigy. And we recently invested in Overlay Analytics, which is a tool for Snowflake, and a couple dozen other ones that I'm not remembering off the top of my head. But so anyway, we at Anthos, we're different from a lot of VCs in that we are not partner driven. Most VC firms, I, as a member of the firm, would go out and find a company that's interesting. I would bring it back, sell it to everybody internally, lead the due diligence, and then own that company as part of my portfolio that I'm managing as they grow. And hopefully I build a good portfolio. We take a different approach where we've built a cross-functional team where we have a team that just finds interesting companies, a team that just does the diligence, and we have a team that's doing consumer insights research. We have a team that just does the financing side. And once it's all done, we hand it off to our growth team, which is actually a totally different team that helps those companies go from, hey, you just got money, now like what does the next milestone look like? And we help them along the way and leverage our network. So obviously everybody works in every department in different capacities, but it's a little bit different that we try and take a collaborative approach because as generalists with a different operating model, our core strength, we're never going to be an expert in one particular category. Like we're never going to know everything there is to know about healthcare or everything there is to know about consumer goods. And so as a result, our secret sauce has to be going from zero to asking really smart questions in a brand new category that we know nothing about in a matter of days. And so to do that, we leverage a wide network of advisors and like resources. When we encounter something new, we reach out to people who are well positioned in various categories to help us, not necessarily do the heavy lifting of answer every question, but at least like help us say like, is there something here? Like, what are the questions we should be asking? How does this fit into the landscape? What are other alternatives and things like that we don't necessarily know about that this might supplant or compete with? And so one of those categories is obviously developer tools and everything around the product management lifecycle. So product management and creation lifecycle. So we look at tools that are, whether it's product planning or coding, development, infrastructure, testing, design, everything top to bottom. We've looked at something that is in that category. And I'm one of the very few people within Anthos that actually has technical or product experience. So I weigh in on a lot of our evaluations, but my experience is primarily web tech, primarily PHP, full stack JavaScript, et cetera, et cetera. So like that's a pretty narrow band in the grand scheme of all of the things that are out there. So if we go look at a tool that is a great product for .NET development, I'm familiar with like the language. I've led a .NET product team before, but I've never written .NET code myself. So that's an area where like I don't never necessarily have any expertise. And we've been kind of like figuring out how do we get smarter on those kinds of things a little bit faster. A lot of our advisory network tends to be CTOs, CIOs, directors of XYZ. And so we've long thought it would be a great idea to build out a network of developers that we could turn to whenever we need real life feedback on tools or platforms. Sometimes that's just a quick opinion, like, hey, is this a thing? And I was actually going to work on a presentation, like I had the whole meme thing of like, is this a, but it didn't anyway. It was those jokes are never as funny in reality in presentations as I think they're going to be. But anyway, so sometimes it's like just simply asking a question of like, is this something that's interesting? And other times it's, hey, we think this is really interesting, but we need to like really understand, like, does it live up to the promise that it says? Or, hey, this is interesting, but like, is it something that you would pay for? Or like, survey questions about like, if you were to use this, what would you be getting rid of? Or would it be augmenting? Or what do you use to do this instead? Or try out these two things and like, how do they compete head to head? We recently looked at, we didn't make the investment, but we evaluated investment in Pulumi, which some of you might be familiar with as infrastructure orchestration. And Pulumi competes head to head with Terraform. And so there were a lot of questions around like, well, what's the benefit of this versus that one? And, we eventually developed a thesis on that. But if we had a group of people that were, even a handful of people who were experts that were doing this every day to be like, oh, you know what, I tried it out and this is what was good, this is what was bad. And the nice thing is, at the end of the day, there's no wrong answer. We're just trying to get to smarter questions. And so anyway, so I've always thought like, oh, this would be great if we had this community, but building a community is hard, as you guys might know. And so, and then one day it dawned on me like, oh, you know what? I've actually been a lurker in the SGF devs like Slack and the Discord for years, and sometimes popped in there like when I was hiring freelancers for alumni spaces or for Lat Long. And so I think I've probably talked to a handful of people here about different projects over the years. And so one day I was like, oh, this network already exists. So I reached out to Mike to come up with, hey, what would this look like? And, my goal is to have Anthos not just like write a check and be like, hey, here's money, like be our farm team now. Like I want to figure out like how we can add value beyond simply being a sponsor who writes checks, because, obviously being from the area, coming back quite a lot. And like, at one point pre-COVID, like I actually thought I was moving back to Springfield, and like for a lot of reasons it didn't work out. But I'm really excited about the entrepreneurial ecosystem that's started to evolve in Springfield in the past decade, and I want to make sure that I can leverage all the resources that I have to foster that. And so, I'd love to hear how we can be an asset to the organization or individuals as we go forward. And we're planning to devote time from our investment team to participate in local pitch events for feedback things, whether it's through the eFactory or other organizations. We're planning on tapping into our network to help bolster some of the speaker lineup for the next Method conference and things like that. So like we're going to generally make our team available to provide value where we can throughout the process. And at the end of the day, we're successful if you guys are successful. And hopefully, this can be the kind of thing that also like, hey, we're trying out this stuff, could be a catalyst to expand the SGF dev group itself by you guys reaching out to somebody who is an expert in this category to say like, oh, hey, we're doing this thing. Like, that might be a good recruitment tool as well. So we already have a couple of things lined up to dive into here in the next couple of weeks. Databutton.com, aviator.co. And then we'll probably revisit Fig. One of their closest competitors is called Warp, and we'll probably evaluate the two of them head to head. So like Mike said, most of these things are probably going to happen in Discord. We'll probably have some like, one-on-one or small group like video calls to chat about stuff as we go on. We're figuring this out as we go. I have no idea how to do this. None of us have ever done this kind of thing. So like, hopefully the discussions and test drives end up being like good exposure to new tools and can be fun. Long term, I'd love to create a way to reward individual participants. And I think sooner rather than later, we have a method for being able to offer everybody in the group some like discounts for our portfolio companies, like basically get our internal rate for if any of our portfolio companies offer services that would be useful to you guys. So I'm still working on some of that, but hopefully we'll have some of that closer, maybe towards the end of the year. But anyway, so all of that just to say, I'm really excited about being able to do this and partner with some folks that I've been able to tap into the minds of in the past, and hopefully can be a great catalyst for making some cool magic happen for the future. And I'm happy to answer any questions or anything like that if anybody has any.
Hey, Andrew. Thanks for everything there. And if you might want to mute your stream feed, because I'll talk here for just a minute, and you should hear me real time right now. But anyways, thanks a ton for that. If there are questions, he is on Discord, Kaforik on there. So reach out to him on there, and you'll see this activity start to spin up pretty quick. But if there are like any huge pressing questions right now, we could probably get a couple in real quick. I just wanted to say too that the involvement of Anthos in this is going to help Springfield devs a ton be able to do bigger and better things. Andrew mentioned Method. One of the hardest things when we were running Method was getting the sponsorship money to be able to make things happen. We did it, but it was insanely hard, and having the cushion for that's really going to help. We're likely, not saying for sure, but likely going to see a Method in 2023 come back. So that'll be big. Holiday party, just having some extra cushion to do fun stuff is going to be really big. And then also I get asked occasionally, hey, can I donate to, help? And we've never really done that. I know Meetup has sent out like automated emails in the past, like saying, hey, chip in and help out. We've never requested that. That's not anything we've ever aimed to do. This is always a free thing. We've never wanted to take money from individuals. So if you feel so inclined, something like this is the perfect opportunity, right, to start, helping out with dedicating just a bit of your time when you see these opportunities pop up to help out with that would be huge. So, yeah. And then, like Andrew said, eventually, that might look like getting some discounted services from these players and such, and we'll figure that out more as time goes on. But anyways, don't want to eat up any more of the time. Andrew, seriously, thanks a ton. Find him on Discord if you've got any questions, but otherwise keep an eye out for announcements of where those channels are. So, great. Thanks, man.
Thanks, guys.
See ya. Matt, take it away.
Thank you so much, Mike. That's really exciting. I'm looking forward to seeing some of these announcements and stuff like that. Real quick, there's not a ton in terms of community announcements. The only other thing I'll mention, like I always do, is every Tuesday here at the eFactory, the Open SGF group meets. So if you're interested in volunteering some of your time for some nonprofit projects, meet us here at the eFactory at 6 p.m. Every Tuesday. Outside of that, some internal group stuff to announce real quick. We are currently workshopping ideas for the Christmas party this December. If you have any suggestions or anything that you'd like to do, feel free to drop them in Discord in the committee events channel. Tiffany, who is the head of our events committee, she'll be responding to those kinds of things and figuring it all out. The only other thing that I'll mention is if you aren't already, be sure to sign up as a member on the Springfield Devs website. That certainly helps us from like the sponsorship side, because sponsors love seeing all those members and all that kind of stuff. And also it's just a great opportunity to network and whatnot.
What's that URL?
sgf.dev is the website. Yep. Okay. Now does anyone have any other community announcements real quick before I? Okay, cool. So without further ado, let's jump into the actual presentation for tonight. Tonight's presentation is from Fred Lawler, who's going to be talking about some Linux stuff. I'm very excited to learn what it's all about. So Fred, take it away.
Go Fred!
All right. Speaking of cool tools, I can think of nothing cooler than eBPF. So I'm Fred. I work for Cloudflare. I'm a Linux engineer at the company, and I'm presenting on eBPF, which is a really exciting technology that has been introduced to the Linux kernel. It has security use cases, it has performance monitoring use cases, or it has general observability use cases, and it's a really interesting technology that can really enhance your ability to debug complex problems on your system at runtime. So this is really exciting. Cool. So this is a high level overview of eBPF. So this is it. I'm just joking. So it's easy to think about this from looking at it from the bottom up. So starting from the kernel all the way up to the user space, and then we'll ignore the use cases. We'll get back to those, but we'll start at the kernel. So the general process of how eBPF works within the kernel is you have a bit of code. It gets loaded in, and it gets verified by a verifier. And then once it's all loaded and verified, it then pins it to file descriptors within the kernel. So you can, if anyone's unfamiliar with that terminology, basically you can read and access the program code at will. We won't get into that in this presentation, but it's there. And then they also contain a generic data structure, which are called maps. They come in very many forms. They're backed by a lot of different algorithms as well. It's just simpler to think of them as JavaScript arrays or PHP arrays or any of that sort of thing. So then, once everything's all good in the kernel, we can then focus on user space. So user space programs can actually load BPF programs into the kernel itself. So that way you don't need to reboot your servers or your Linux environment or anything like that whenever you want to load a new we call them modules in. So that's really advantageous because that means you can actually run this code at runtime while you're actually getting real traffic into your systems. So you can really dive in and check out and see what's going on with your applications. So with that said, some languages that can be used to load programs they're right there. But what's not shown there is unless Python changed their logo to that red snake-looking thing. But Python, Go, C, Rust, these are all languages that you can use that to basically inject your BPF code into the kernel at runtime. The caveat is that your eBPF programs are still typically written in C, and we'll see a little bit of an example of that in this presentation, but I'm not going to dive too much detail into it. But you use your user-based applications, and you can take that C code and basically compile it down into machine instructions, and then use your user space applications to inject them into the kernel. So put together, it's a very complicated, flexible, and amazing tool to use and leverage. Cool. So how is BPF WebAssembly for your OS? So we're going to take a little bit of a deep dive into the kernel aspects a little bit. I wrote this description as, think of WebAssembly for your OS, but the analogy of it doesn't quite make sense until we actually look at the machine instructions. So at its core, eBPF programs are machine code just like any other program. As I already mentioned, they're loaded in. They're very specialized instructions. So the instructions that are loaded in are very different from what you might see for ARM or x86 or MIPS or anything like that. It's very limited, very small, does very little, but it has a lot of power behind it. So there's and with that, there's some limitations to what you're able to do with this. So in some cases, your function stacks might only allow you to have 512 kilobytes worth of program space. So when you compile your code, it generates all these machine instructions, takes 512 kilobytes. That's not good. That program probably won't likely load or be verified. Very easy to run into this situation. Can be overcome by using maps. But that's a little bit of a topic that we're not going to really get into. But you can use them to allocate extra memory and use them as kind of like a little miniature heap within your eBPF applications. So the tricky bit is that eBPF programs cannot crash the system. So if we're familiar with infinite loops, eBPF does a very good job of not allowing you to write infinite loops. So I thought this was just a little funny tidbit to add in here. Your loops have to be proven to exit in order for the verifier to say, this is good. Otherwise, your system will crash, and we can't have that. So let's actually take this up a level. So who cares about WebAssembly? Let's stick to C, right? C is a lot easier to understand. So like most software, machine code is abstracted to a higher level language. In our analogy, we can think of like C being compiled down into WebAssembly. Now, the tricky thing about writing eBPF code in C is that you need to use the Cling toolchain and target BPF to compile. In order to compile, I'm not aware of any GNU targets that will compile this down. Everybody uses Cling. Not all C can be compiled. So recall I said that the machine instructions are very limited. The same is true for C. So in my particular case that I ran into, if you have an arbitrary length array, and let's say it's a two-dimensional array, the compiler may not be able to recognize and compile out and do all the proper stack alignment. So when it comes time to do the actual execution of your eBPF program, your arrays are not going to be accessed, and you're going to run into all sorts of problems. So I thought that was a really interesting thing that I ran into recently, actually. Helper functions exist interfaced with Linux. We can actually see one right here called bpf get current task BTF at the very bottom there. That is used to get the current task. So when you start working in this C layer, it really opens up to more library usage. You actually have access to kernel structures, and you can read them, and you can sometimes manipulate them and do interesting things. This program in particular is to block user namespace creation with unshare with the unshare syscall. But here's some links that you can get started with. Particularly, libbpf bootstrap has been a godsend. It is basically a gigantic list of examples that you can compile, run immediately, and everything is hunky-dory. You can start seeing what's going on. And there's also Go and Rust support. I already mentioned that, but there's a direct link right there. But that's it for C. Let's take it up another level. So now we actually kind of see where this analogy is kind of going, right? We went from WebAssembly, or assembly in general, to what you would write WebAssembly with, like in C or any other language. But now we're going to try to branch into the JavaScript analogy. Now, eBPF, if you ever visit their website, they really love to boast that they're JavaScript for the operating system. And in some ways, they are not wrong. Hello world, look at that. Very nice and simple. JIT compilation. Perfect. C-style scripting language. Just like in C, you can also access structs and other kernel features as well. But we will dive all into this later. So let me introduce you to bpftrace. But before I do that, we have to talk a little bit about a dev environment. So the problem with eBPF is that it doesn't come available for all your kernels and all your Linux systems everywhere. There is some level of configuration that needs to occur, and not all cloud providers may provide this information as well, or provide kernels with this information. There's only a few providers I know of that may allow this, and that would be if you're working with EC2 from AWS. I do know that they allow you to upload your custom kernel into your instances. And with that, then you'll have access to eBPF. Anyone that uses other hosting services, you might need to contact your provider to see if your cloud hosting comes with any eBPF enabled on it. But otherwise, I created a dev environment. So that's right. Anyone here or watching online can go download this repository right there and spin up a virtual machine that is perfectly configured, perfectly ready to go to start writing eBPF code with just a easy click of, or easy typing of make run and then your preferred computer or operating system, whatever you use. Run Windows, run Mac. Cool. So we talked a lot about the underlying infrastructure and how it works. Let's see some of these use cases in action, right? Networking, security, and observability and tracing. Yeah. We're not actually going to demo tonight. Demos are hard, especially live and on other people's computers. So what we're going to do is we're going to look at code and examples just by pushing a button. So let's start off with bpftrace --info. So this is a little bit self-explanatory, but what this essentially does is this one tells you that A, you have bpftrace installed, and B, what all in your kernel is actually enabled. So you can kind of see all on the, the right-hand side? The right-hand side, all the things that is enabled on this particular system, and this is a part of the actual dev environment. So everything's basically enabled with a few exceptions. And that lets you know that this is what support you have and what you can basically do with eBPF on your system. So bpftrace also comes with an LV. Options for the command. In this particular case, -L will list out all the available what are called probes or hooks on your system. V will print out like what their arguments take within those hooks. And we can see right here, this is just a small example of clone, but we have a lot of options here and a lot of trace points and probes and a lot of things we can hook into. But for those of you who don't know, clone is essentially it's essentially the syscall to perform, to create threads in your system. This is the total amount of probes that were offered at this time. Kprobe, krep probe, urep probe, blah, 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 blah. I'm not going to go into detail into all of these, but we're actually going to explore some of these. Kprobe is used to hook into kernel functions. Uprobe is used to hook into userspace functions. Ureprobe is just like uprobe, except it's specifically targeted towards functions that you're trying to track, like the return of them. So this is we'll see in later example how this is exactly used. And USDT is kind of similar to uprobe, except that these are often added to. This is often added to software itself. We have an example of that here in a bit. All right, so let's actually start off with an actual program. So let's log all the shell commands. So the eBPF language is fairly straightforward. It always starts with, you don't have to, but it can start with a begin, and you have a block of code, and you can print some information. Very similar to C in the sense that you really can use all of these same formatting options for your print function to get some sort of information across. And then from there, you can start listing out your probes. In this case, we're leveraging a urep probe to target the bin bash executable, and then every single time it reads the line. This is it. This program will literally log every single time someone writes a command into anywhere that's anywhere that's in bash specifically. I need a caveat with that. Anywhere that's in bash specifically. There's a time function that lets you obviously get the time, and then down below we have print that prints out some more information. PID is a special variable in bpftrace that's reserved for the process ID. And then the str rep file. So for those who are not familiar with low-level concepts, when a function returns a pointer, it can really point to anything. Now, usually pointers have some particular type to them, but BPF is very agnostic to that. So it kind of treats like every pointer as you kind of don't know what it is in terms of a rep val. So or in terms of a ret probe. So we have a special variable called retval, which is the actual return of the readLine function, and then we get the string of that. So basically, what we're saying here is take that pointer and treat it as a string, and then it prints it out. So let's actually see this in practice. So with the screen command, I load this program into the background. It's important to do this because with eBPF programs, what generally tends to happen is you'll notice in the last slide I said, well, push Control-C to close this. Right, so these kind of run as a long running process, and when that's the case, if you have it like in your foreground and you're running it in front of you, it's really hard to type in things if you don't put it into the background. So we use screen to put in the background, and we start writing shell commands. Echo hello world, prints out hello world. Time, give me the time. And then what we do is we inspect it. So when we go back into the screen and close the program, we actually get the actual full results of what we just printed out or typed into our terminal. Now, for those of you who are very astute, will notice that echo is not printed in this list. This is actually a good point. These programs have a fairly long startup time because remember, it has to essentially load into the kernel, and it has to start attaching probes, it has to do all these things, and that takes time. So when we're working with bpftrace, there's a little bit more of a startup time to them than say with a typical C application or just the machine code in general. And in this case, it was still loading while I was typing echo hello world, so it didn't catch it. But as you can see, we have the actual time and the process ID in which we wrote our commands. So, this could be really helpful if you're trying to, if this was, I don't know, whatever that TV show is that always has hacker people on it. They could use this to do their filming because then you can just have someone typing away and it just lists all the commands. I found your hacker. But let's look at a more involved example. So this one is a little bit more tricky to understand what we're trying to do here. So I'll try to be as plain as possible. Typically, programs, when you execute them, they may only be able to be executed within like certain permission constraints. In this case, we call them capabilities. We can kind of see right here that at the beginning of our program, we set up a list of capabilities. Anything noted by an @ symbol and then a name and then like some array access, this is our map that I was talking about earlier. So this is where it gets really flexible. They are global to all your probes within your program. So you can see we have the begin and then it's then later accessed in the cap capable probe. But we do our setup. And then once we get into kprobe, we're looking for whenever the function cap capable is called. This is a kernel function. So within this probe body, we have $cap equals arg2. So local variables are denoted by $, and then some name. And then we assign them the arguments of the actual kernel function. So in the case of cap capable, we have, I believe there was four arguments. So we have to access them through arg2 and arg3 for this particular case because those are what cap and audit are within that function. And then once again, we see the use of the time function, and then below we do some printing. So let's go see what programs actually require certain capabilities. So we're going to go ahead and load that in. And as we load this in this particular case, we don't need to really type anything or do really anything with screen. We can just kind of like look at what's going on. This gives us a stream of everything in our system that is requesting capabilities, essentially. So we can see here that systemd is requesting the capnet admin, and then screen is using set GUID or set UID, or not GUID, sorry, GID and UID, which are user ID and group ID respectively. Permissions, and I have a link down here for all the cap documentation. It is C code, so don't be too intimidated by it, but it's really easy to understand and learn what these different capabilities do. But yeah, you can actually inspect and see like what programs are requesting what capabilities. It wouldn't be a fraud presentation without MySQL, am I right? What? No. Come on, I want to hear it. I know what you guys are thinking. I don't have any examples of this. I didn't want to install MySQL onto my virtual machine, but this is a good use case of USDT probe that I mentioned earlier. MySQL does provide us BPF support, and what's really cool about this program is, in typical Fred fashion, I want to know all queries that are taking way too damn long to run, because those got to be fixed. So, once again, we'll start off with our preamble. We're already familiar with that. So let's get down to the USDT probe. So we're saying we're going to attach a USD probe to user bin MySQL binary, right? And then we're going to listen on the MySQL and then the command start. So whenever this gets called, we see our maps are going to get updated. So TID is similar to PID, except we're talking about a task at this point. So in Linux, process IDs and task IDs are different. Tasks are essentially processes, but PIDs have a little bit more meaning associated with them. So whenever a new command, so in this case a new query or whatever's in that list of commands, whenever a new command comes in, we're saying, okay, we're going to associate that command with a process ID, and we're going to pass it in the argument, and then the start TID. So now we're actually going to get into a use case of where we're measuring latency between start and end of our query executions, or in general, or whatever these COM commands are, executions. And then when we get down to the next probe, we're listening to when they're done. So when they start and when they're done. So USDT, user bin, MySQL, MySQLD, MySQL command done. And now we get into filters. So BPF has the concept of filtering. So when your probes are actually listening for incoming events, you can actually filter them. So you don't have to capture everything all the time. You can actually filter them down specifically. In this case, we're looking for all the ones that actually exist in this map called start, and then has an associated process ID. So we're saying for anything that's in that list, go ahead and filter out everything else and only focus on what's in that list. And then we have another local variable where we actually do the time calculation. More stuff. Histogram is an interesting function, because what that does is, and I'm sorry I don't have a slide for that, but essentially it produces a nice graph of like it's just a graph. It's just a histogram graph, bar chart, if you will. So it can kind of give you like some visual indication to prove some point, like, oh yeah, this thing is taking forever. Here's how much longer it is compared to everything else. You can actually modify how big and what steps your histograms take and things like that, but we're not going to get into that here. And then we have the delete command. So as you might imagine, we have to do some memory management here. We do want to delete what we've already put into this list, and that's what delete serves. So whenever you see a delete command, we're basically saying remove this or free up this memory from this location. And that's that. I wish I had an example of this, but this is actually pretty cool. It's really interesting to check out. The program does exist in the setup repository that I have, so you can kind of like use it on your servers if you have BPF enabled. Just make sure to use bpftrace. Okay, now the moment we've all been waiting for, the last slide. Not really. This is our last program demonstration, though. So this actually came up at work last week, not last week, a few days ago, as a matter of fact. And I thought this was a really interesting use case. So when we're looking at at all of our programs on our systems, sometimes it can be the case that, oops, we have a program that's using up too much memory. How do we find it? Like we have spikes in our memory. What do we do? So this is a very practical example of how you might be able to find leaky programs within your systems. So this time I left out the begin part. So let's get right into the meat of the code. So we're going to say urep probe, and we're going to now look for this scary little bit at the top, that is actually a path to the libc. We'll just call it binary for all intents and purposes. Now, for those who are not familiar, libc is like your go-to standard library for all things in C. It contains like all your functions for allocating memory, freeing memory, or string manipulation, or you name it, it's pretty much there. File operations, yada, yada, yada. So we can actually use BPF to hook into these functions and actually perform, well, actually do observation on all of our programs with our system that actually call these functions. So this is a very powerful technique that you can really leverage in your business applications to actually diagnose and find problems. But enough of that. We'll get back into it. So we're looking for, so similar to the last example, we're looking for a start and an end. In this case, we're looking for a malloc, and mallocs must always be caught by a free. I need to put that out there. Always free your memory after you allocate it. So we have another case of we have a map that we're looking for the return value of malloc. Now, so malloc returns a pointer to basically the first address of where your memory is allocated at. So we're gonna track that and assign it to the special variable called com, which is the in Linux, com is the name of your process. So as we've seen before, MySQLD would be the com of MySQL, and systemd would be in the previous example would be another one, screen, yada, yada, yada. That's the com. And then we're going to say for each of those coms, we're going to create a new map and then do a +1 so we know that we have an allocation. And we're tying back the allocations to these process names. And then we're going to use a urepprobe. Now, remember, we need a repprobe for the first one because we want the result of malloc. And then we're going to use a uprobe because we want the actual income into this function, so the entrance of the function free. So then we're going to take the coms and we're going to locate it back. So arg0 would be the address that we're trying to free. So we take the map it, and then subtract 1, and then we just delete it. And that's basically it. Very simple, very powerful. So in practice, it looks something like this. Vim made a lot of allocations. Now, there are a couple bugs with this program that I've since tried to address in the actual example repository. But I challenge everyone to kind of think about and to play with this on their own and try to actually improve it. So, for instance, this actually shows that we have a leak, but do we know why and where? Tough crowd, nice. Okay, well, I'm just joking. It's cool, it's cool. We do have a leak. bpftrace is pretty much our leak in this case. It's a long living process. So we're actually making a lot of calls into these probes, and it's probably doing some sort of allocation behind the scenes with malloc, and it's not being freed. So in this case, we do have an actual leak within our application. But the interesting thing here is with Vim and Screen, why are they on this list? Those who are familiar with memory management would know that when a process terminates, so does the allocations with it. In our case, when Vim exited, we didn't clear it out. So that's one of the bugs in this application. We don't have a probe to actually check for on program close removed from this list. Another issue that this program has is that we're not actually tracking the specific process ID what if we have multiple VIMs? How do we know which is which, right? So that's another bug with this application. So in the actual code, I wrote out a whole bunch of comments saying like, these are exercises that you can do on your own. And I encourage you to practice them and to actually fix these problems. I even gave some hints. I wasn't too nice. I didn't say exactly where to find these things, but it's there. So anyway, I really love this stuff. Anyway, so let's talk a little bit about resources. So Brendan Gregg is kind of the person who introduced bpftrace. He has an entire book on performance tools, and these were originally written in what's called in technology called BCC, but they've since been ported over to BPF, right? BCC are just normal BPF programs basically wrapped around in Python. As I mentioned earlier in our eBPF in a nutshell slide, Python should have been listed there as like a wrapper in userspace to execute eBPF or to load eBPF code into the kernel. That's what BCC does. But Brendan also has a book that also goes into BPF details. So this book is fantastic. I think it's free online. I do have a link to it. I sometimes reference it. There's also eBPF IO that has a ton of resources. Especially if you click on the resources in the link, there's a lot there to get started with all things eBPF. So this book, great. If you want to start using this this technology in your businesses, this is the book. Lots of examples, lots of cool tools, gives you great ideas to move forward and to write your own programs to find problems within your systems. These are all the links to the slides, on all the slides. Feel free to go through them at your leisure. I do want to point out, though, specifically that we have this one link here at the bottom called the elixir.bootlin.com/Linux. That is like the best place online to look up kernel functions, functionality, structs, you name it, it's all there. It will tell you everything you need to know about what's going on, because it is the Linux source code essentially, but it's searchable, so it's a very fantastic tool. Okay, now the part that people are gonna be excited about. All right, you guys ready for this?
I have a question.
Yes.
So can I use BPF to like block things or certain syscalls or behaviors from programs? Like say like I just don't want a certain program allocating too much memory through malloc too many times. Can I use it to block, or is it only for monitoring?
You can use it to block. Oh, sorry. The question was, suppose I have too much. I have a program doing too much memory allocations. I want to limit how many memory allocations it can do. Can I terminate the program? Yes, but I would recommend using it with. I would recommend writing such a program like that with the actual C version of BPF because that actually gives you that capability to essentially block it. Now, but it gets a little tricky because there's certain areas of the kernel where, like, we talked about probes. Those are mostly for observability cases. What I haven't talked about were security, the Linux security modules subsystems. So that is something I'm deeply familiar with at work, and you can actually use that to exit your programs with eBPF. Now, as far as like specific memory goes with BPF, like if you're talking about the case of malloc and free, you can with like there is a feature called override return, and if on a malloc, if you return null, then memory wasn't allocated. So that could be a decent way to block that with the eBPF code. Yeah. Yes.
Got a couple questions. The first one is when you were talking about the MySQL stuff, you mentioned that MySQL added support for eBPF.
Mm-hmm.
What do programs need to do for them to support these various hooks in eBPF?
Right. So I was asked, what do user space programs need to do to add in their own hooks that eBPF can essentially leverage? I don't know. I actually tried looking into that earlier this week, but I was distracted with trying to make the presentation. So, yeah, no, that's actually a good point. I would definitely, I will look into that, and I'll let you know in the Discord and everyone else in the Discord, because that is a fairly cool, or that's a good question, but it's also a fairly cool thing to do. So, yeah, of course, I'll help you out with that.
So second question, if the answer to this one is like dark magic, I think it's a valid answer.
Mm-hmm.
Do you have any insight into like the underlying implementation for eBPF? Like how is the kernel actually like allowing different code to run when like a certain function is called and do things? Like what is happening underneath the hood there? And like I said, dark magic is a valid answer.
I was asked what is essentially happening under the hood with these eBPF calls. Like, how do they get essentially how do they get invoked? Dark magic was suggested as a valid answer, and I'm going to say the short version is dark magic. The long answer is you can. I mentioned the various probes that can be attached, right? Some of these, like tracepoint, for instance, they're baked into the kernel. So whenever a function gets called, there might be a tracepoint already as a function call within a function already in the kernel. So that's one way, right? Another way with LSMs, there's security hooks that we have for that. Obviously, LSM's not listed here, but it's an option in the actual C version of eBPF and not eBPF trace. Rep probe and user probe, or K probe and user probe. Oh, did I accidentally delete it from the slide? Rep probe is there's another one that should be right above it called U probe, which is my bad for removing that. That was a mistake. But anyway, now the way those things work is it could be a little bit different. That's where the black magic is. You can actually look at the addresses of where functions are located in the kernel, and I imagine that's essentially what's going on. I don't actually know for sure, but I imagine that's kind of like the direction you would have to go in that case, especially when you're looking at user space libraries, because the kernel is not going to know like everything about those binaries by the time you call your functions. There has to be some sort of way for these libraries to basically say to the, or like it's like baked into the binary itself of these libraries of where these address locations are and like what their symbols are. In the case of not symbols, I didn't bring up a presentation of this or a slide of this, but in the BPF in the BPF trace reference guide, they actually do divulge a little bit into actually targeting literal addresses, memory addresses, where functions might be. And that's kind of like some of the ways that it works in that case. There's also another underlying technology called BTF, which is BPF type format. That is another way that kind of like, to put it simply, it takes all your symbols of the kernel and it basically generates debug information. So symbols, things of that nature in which you can use your eBPF programs to hook into and actually leverage. In fact, we can kind of see that in this, ooh, went back too far. This one. In fact, we can actually see a little bit of that right here. When we look at the task struct, we have a specific attribute called preserve access index, and this tells the compiler to. This basically tells the compiler to try to keep it very similar to the Linux definition. Do all the mappings. This is technology called BPF core. Compile once, run everywhere is what that stands for, and essentially the underlying technology for this particular program right here, which basically maps these structs to the structs in the kernel code. Not necessarily, how to put this, without getting into too much detail, essentially structs are aligned a certain way. So core relocation is going to happen to match the symbols with the actual addresses of where these bits and pieces of information of this tax struct are actually stored within the kernel, and then swap out pointers and addresses and look it up and do things with it, dereference it, do stuff. I hope that answers your question. Yes.
You were talking about, where was the memory overrun? You said it was on that, whatever the number was, 433.
Mm-hmm.
How did you know that? What tells you that that's the memory error?
Ah, very good. So I was just asked when we were looking at the this part right here, how do we know that bpftrace is actually leaking memory? So that's actually another exercise I forgot to mention within the code. What you can do is you can actually run these programs essentially at certain intervals. There's an interval probe that allows you to say run these print statements every so often based off of like some metric minutes, seconds, other resolutions. And you can kind of see, like, when these things grow over time as you're observing it, that's when you know that, yes, we have a memory leak, because we can see these counters constantly going up and not going down. This is very useful if you kind of tie this into some sort of dashboard that you might have. You can certainly do that, but the caveat is when working with specifically BPF trace. It's not exactly known for its speed. It's great for looking at like things on the fly when you're in a quick pinch. But ideally, what you would do is to really improve performance with looking at this information. You would write this in C code, load it into the kernel, and then you would use what's called like a ring buffer to buffer all these events, and then pipe them out over to some sort of observability tool to kind of monitor like. Here's all the programs on the x-axis, and the y is the counts and the memory allocations. You can kind of look at that and kind of see and gauge like, oh yeah, we have a leak when we see something that's just like going all the way up. I hope.
You can have a benchmark in your mind or something that you've been observing for a while before you know that number is wrong. Is it the memory error?
Are you asking if there is like, would you know ahead of time that there's memory error? Well, yeah, I mean, absolutely. Like, I mean, any observability tool worth its weight would let you know that, hey, look, you're using a lot of memory. This is a great way to say, BPF would be a great way to say, wow, we have this problem. What's actually causing that problem? So you can kind of use this to get your initial reporting and then say, okay, well, let's actually dive into this a little bit more and find out what's going on. Now, practically speaking, your observability tools might actually already tell you which processes are doing this. But if you're not in a position where you're set up for that, this could be a good indication of or this could be a good way to just kind of jump in there and do that. This is just an example, by the way. So this stuff is great. So you can really balls to the wall, do whatever you want with it within reason. So it's really nice to pinpoint problems. Anyone else?
What kind of overhead does this add to like a system? Like, do you have to if you're in a CPU constrained environment, do you have to you have a bunch of probes on malloc, something's caught on malloc, you have to be concerned about that?
Yeah, so I was asked what are some. Well, hold on. Let me understand if I got this right. So are you asking me what is the performance impact of running? Okay, right. This is a little bit. This is where filtering comes in very much handy. You obviously do not want to run this code on for everything within your system. You do want to filter it down as much as possible. You do want to. Prefer not logging back out, because when we see this information, we got to remember that these programs essentially have two-way bindings from your user space application and into the kernel. So when we actually log and print information from these programs, we're saying gather all your metrics and then shove them up to user space, right? And that takes time. So that's why I forget who asked the question, but that's why when you have something like a ring buffer involved and things like that, you can actually hook in other user space applications into these file descriptors that I talked about and actually read the maps directly and gather information from there. So that way you can kind of alleviate some of these performance problems that you might encounter with this. Now, I'm not saying this is very fast technology, right? Like you're saying I want to put something directly in the hot path of some function. You can just imagine that something that calls malloc. If you're having programs that are in a tight loop, constantly allocating memory, yeah, this is going to slow things down by quite a bit. But in situations where you're not in a tight, tight loop situation, it's fantastic. But when you're in those very tight situations, frequency does matter. The more you call these functions, the slower things get. The less frequently you call these functions, everything's a-okay. It's basically the gist of it.
Fred, we have a question from chat.
Yes, chat.
So can a Linux admin detect or manage or stop eBPF programs? For example, would I be able to find or stop your eBPF code that is logging all the bash commands?
All right, so someone from chat asked me if we could essentially stop eBPF from executing, right?
Or at least stop your script in particular from like your examples.
Yeah. Can I ask a clarifying question, like with eBPF or without eBPF? Maybe both.
I'd say without.
Yeah, it's kind of like
imagine I'm an SRE and a Cloudflare.
Yeah.
And I have some guy running eBPF on my system that's slowing it down.
Yeah.
And I need to stop him.
Yeah.
Yeah. How do I do that?
Yeah. I never thought about that. That's an interesting. I know, like from the kernel perspective of how you can say don't allow BPF, but if let's in this particular case, we know it's a user space application, right? So you can just kill it, right?
No, so it can show up as any other process.
Yeah, exactly. Yeah, but when we're talking about why did I say I don't know? I actually do know this. But when we're talking about already loaded programs, especially from the C perspective, recall I said that we had file descriptors and they're pinned. You just remove those links, unlink, and or remove the file and it's gone. So those are your two ways to do it. BPF trace, you have to kill the process. Normal BPF, remove the link.
I don't know this person in Discord, but can I list what's running somehow? Like what's loaded and currently probing?
Yes, there is a command called, excuse me. I was asked, is there a way to list what BPF programs are essentially loaded into the system? Yes, there is a program called BPF tool. And you can actually list all the running BPF programs, maps and links, or not links, maps and programs, and links too, sorry, drawing a blank, of all the running eBPF code on your system. It literally gives you the file description, the ID, and you can go from there to kill them. Oh, another nice thing about BPF tool, you can actually list out all the source code that's actually in the that's actually running. That's how I got this. I did BPF tool prog. Hold on, I got this. I think it was like xlated ID and then the ID of the BPF program, and then I was able to get the dump of the machine code with some debugging information, of course, too. So you can debug these things. Verifier also does a good job too. I don't have a screenshot of that. I would, at this point in the questioning, I would whip out my laptop and actually spin up the virtual machine and show you guys this stuff. But I don't have Thunderbolt, and this laptop already has the presentation and stream stuff, so I can't do that. Are we done?
What stuff does the verifier verify? Like you mentioned, I don't remember what you mentioned actually.
Oh, okay.
The loops.
Yeah.
What other stuff, like what's it doing when it runs?
Right, so I was asked, what does the verifier actually verify? I did mention loops. It can sometimes do loop unrolling to verify loops and prove that they do actually finish at some point. But it does a lot of other things too. It double checks your function calls. So, in this case, we have our BPF task PT regs. These are, and then the BPF get current task BTF. These are helper functions that make sure that those are called correctly and that you're passing in the right arguments. It's just like, it's kind of like you can think of like a compiler within a compiler, really. It's really to runtime check your code before execution because, like I said, eBPF programs must not fail. So the verifier does a very good job of proving that the code works at runtime. Now, can your code still be buggy? Yes. But it still runs.
What's the weirdest bug you've ever fixed using BPF?
What was the weirdest bug
Or identified?
What was the weirdest bug I've ever fixed or identified using eBPF? Haven't come across a case yet, so I don't have an answer. Sorry. maybe in Discord, if I come across it, I'll be like, oh, hey guys, remember that presentation I did? I bet you do. Here's what I ran into. All right. Any more questions on Discord? My favorite ice cream is not vanilla. I like a mixture of things. Okay, cool. Well, I'm just gonna call it quits.